Central Costa Rica is a sprawling valley which in the past provided drinking water from its rivers and springs. Today, surface water is so polluted that the rivers are a sore sight even to look at, particularly in the urban areas. Dr. Jenny Reynolds, lecturer at the Costa Rica National University and the head of its environmental hydrology laboratory, began to probe the state of the valley's water supply more than 10 years ago.
Well,
I realized that the population of Costa Rica will increasingly need more water. Previously, the main source of water for public supplies was surface water, that is, river water. But since the rivers have been becoming contaminated with time, especially in the lower parts of the drainage areas and in the cities, groundwater has begun to take on increasing importance.
The people of the region switched to the water in the aquifers beneath their feet. In the metropolitan region of the Central Valley, groundwater now sustains more than 1 million Costa Ricans. However, the residents would be better off with groundwater only if it were clean. Coffee plantations, which in the past were the pride and the money of the country, had used too many fertilizers that seeped into the groundwater. When Dr. Reynolds began her quest for clean groundwater, she started to use isotope hydrology, a nuclear technique that is capable of identifying harmful substances even in minute quantities.
First of all, we started to evaluate the nitrate concentrations in groundwater, and we realized that there was an increase over time in these concentrations. Then, using isotopes, we were able to identify the sources, namely nitrogen fertilizers used on coffee plantations.
The IAEA continues to be an active partner in the Costa Rican process. Costly isotopic analysis of water samples is undertaken without charge by a regional laboratory supported by the Vienna-based agency.
The International Atomic Energy Agency provides funds for purchasing equipment and also for training, both for university people and for other participants working in government institutions, and it also sends experts to provide advice in certain areas.
Isotope hydrology for Dr. Reynolds is not an end in itself, but a means to raise public awareness about Costa Rica's water woes. Armed with the scientific knowledge, she and her team work closely with the local communities establishing vulnerable areas.
I think that in a country as small as Costa Rica, a person may be a scientist or have a scientific training, which is necessary to handle information and design a project, but must also make known the results and give recommendations for the integrated and sustainable management of water resources.